Okay, welcome back. We're in Chapter 25 QuizA, question number 1. Chapter 25 talks about paired samples. So obviously there's a little bit of an adjustment from what we've learned in chapters 23 and chapter 24 about inference for means when we have paired samples. So let's take a look at the prompt. Before you took this course, you probably heard many stories about statistics courses. Oftentimes, parents of students have had bad experiences with statistics courses and pass on their anxieties to their children. To test whether actually taking AP statistics decreases students' anxieties about statistics, an AP statistics instructor gave a test to rate student anxiety at the beginning and end of his course. Anxiety levels were measured on a scale of 0 to 10, 10 being the highest. Here are the data for 16 randomly chosen students from a class of 180 students. So here's our pre-course anxiety level, and here's our post-course anxiety level data. But these two groups are not independent because they're measuring information from the same individual. So that's why Chapter 25 talks about paired samples. Okay, data such as these are called paired. Okay. So we're going to focus on the difference in anxiety levels for each pair or for each person. So again, our focus is on the difference of anxiety levels for each person. So that's exactly what you see here. I've calculated the difference in anxiety levels from the 16 randomly chosen students from his class. So if you can just take a minute and put the difference, the post minus the pre-anxiety level, the difference, into list 1 in your calculator. While you do that, I'm going to do the same. Okay, so while you finish up putting the differences in list 1 in your calculator, I'm going to read question 1. Do the data indicate that anxiety levels about statistics decreases after students take AP statistics? Test an appropriate hypotheses and state your conclusion. Okay, before we do our hypotheses test, we know we have to satisfy our conditions. And we have to first talk about the paired data condition. And the data are paired because they are measurements on the same individuals, both before and after the Intro to Stats course. Okay, well, how about that independence condition that we learned so much about? Okay, and independence, the anxiety level of any students is independent of the anxiety level of any other student. So each student's data is individual. Okay, that makes sense. Randomization. Clearly we are told in the prompt that it was 16 randomly chosen students from his classes. And nearly normal condition, I think you can see that we've provided a histogram, and the histogram of the differences is unimodal and roughly symmetric. And clearly 16 is less than 10% of the students who take AP statistics. We've now satisfied all of our conditions. Because n is less than 30, we provided a graph for our nearly normal condition, and we're ready to state our hypotheses. And the hypothesis here is the mean difference in anxiety level is 0. That means that there was no improvement. The student was just as anxious at the beginning of the class as at the end of the class. And our alternative would be that the mean difference in anxiety levels is less than 0. Hopefully AP Stats has actually decreased the student's anxiety. And that's what you would see here. Okay, so now we have all of our data in list 1. We're going to hit stat calculate one variable statistics. All of our data is in list 1, and we're going to find our sample mean. And our sample mean is negative 1.125. The sample standard deviation is 1.147. the number of pairs is 16, and that means our degrees of freedom would be 15. Okay, so this we all got from our calculator. We got all these statistics from our calculator, while the degrees of freedom is just n minus 1. Okay, there was 16 pairs of data. Okay, and our mean of the differences was negative 1.125. The standard deviation of the differences is 1.147. N was 16, our population, which means there were 16 pairs of data, and the degrees of freedom would be 15. It's always n minus 1. Okay, so now we need to plug it in. Obviously, in order to complete a hypotheses test, we need a t-value, and in order to do that, we are going to look at our AP Stats formula. Before we get our t-value, we're going to find the standard error. The standard error is the standard deviation of our sample divided by the square root of n, and that can be given on your AP Stats formula sheet. So it's 1.147 divided by the square root of 16, which is 0.287. So now we have our standard error, and we're going to calculate our t statistic. Okay, and again, I got this formula from the AP Stats formula sheet. They say it's statistic minus parameter over the standard deviation of our statistic. Okay, so our mean difference was negative 1.125. We're subtracting our hypothesized value of there was no difference, and we're dividing by our standard error, which was 0.287. And we get a t-value of negative 3.92. And so now we're going to plug in this t-value and try to calculate our p-value. Okay, so here's our p-value. That's the probability that t with 15 degrees of freedom would be less than negative 3.92. So let's take out our calculators. And we're going to do t-CDF function. Negative 99999 is just a random, very small number to the left of negative 3.92, which would be our upper bound. And always with the t-value, we put in the degrees of freedom. Okay? And when you do that in your calculator, you should get approximately 0.0007. Now, clearly, our p-value is very, very small. And we know when our p-value is very, very small, we are going to reject our null hypotheses. So with a p-value this small, we can reject the null hypotheses. We have strong evidence that taking AP Statistics class reduces the anxiety level of students. Okay? Tune in again.